Alright, so in question 9 we're going to find some information about this side. We're going to show that HD is 1/6 of the whole length AC. So that's our aim. So to do that we're going to look at the line segment AE, and we know that G is the intersection point of the medians, and we've learnt a ratio here. We've learnt that we can say this is K, then this larger length is 2K. Another bit of information we have in this question is that AF, so this length here, oh my mistake, AF here is equal to FE. So those are equal line segments from this bit of information. So what we can say is that if we add up the lengths, we can divide by 2 to find AF. And to make that a bit easier to divide by 2, at the moment we've got the whole thing being 3K. So instead of saying 2K and K, let's say 2K and 4K, 2K and 4K here, so that we can divide that more easily. So the whole thing here, AE, the length of AE, let's just use some notation here. At the moment we've got it as 6K, and divided by the ratio 4K to 2K. Alright, so then to divide that by AF, we know is half the length of AE, and so we know that that's 3K. Alright, so that we can transfer all of this information down onto our main diagram here. So AF is 3K. This F, now that would make this FG K because the distance from A to G must be 4K, and GE is 2K. So that's the first part of this question here, just looking at the ratios. And another ratio that we have another median here. We've got, if this length here is M, then this must be double that, just using that same median ratio there along the length BD. So now that we've got these two ratios, we're going to use this ratio and this ratio to find the ratio is true. To do that, we're going to make some similar triangles by drawing a line parallel to BH. So that now when we do that, we see that there are a couple of similar triangles. We can see a small triangle here and here inside. So those two triangles are similar. So let's write the similarity statement. Of course, to do that, we need another symbol here. So let's call this point I. So there's the similarity statement here. GID is the smaller triangle here. It's similar to the bigger triangle, BHD. We know that the angles are equal because of the parallel lines, and D is a common angle. Alright, so then we can compare now the ratios of the side that we're interested in. We're interested along this length here, AC, right? So we can take the ratios along that side, so that would be ID, the length of ID and the length of HI. And we can use the ratio, the red ratios here. We know it's M to 2M, the ratio of the sides. So that ratio must also hold here. It must be M to 2M, which is a half. And so let's call this length N, let's say. We haven't used N yet. So HI must be 2N. We don't know what it is, we just know that it's double. Alright, so now we can find a second similar triangle because we've drawn this line parallel to this line. We have another similar triangle if we look back up this way. Alright, so let's write the similarity statement for those two triangles. And again, because of the parallel lines, we know that these angles must be equal and they have the common angle at A. So the reason is that they have two angles in common. Also, we should have done that up here, the reason for the similarity. And so here we can use the blue ratios here. We've got 3K to K is the ratios of the side length there. So we can look now in our yellow triangle at the ratio AH to HI. Now we know what HI, we've got a label for HI, it's 2N, right? Let's not get too far ahead of ourselves. Let's first write 3K to K. That's the corresponding, so it's the ratio is 3. Now, but if we have 2N for HI, then AH must be 6N to make that equal to 3. And let's write that on the diagram, 6N. And remembering right back that, remember G here, G, this point here, this important point G, is the intersection point of the medians, which means DC is the same length as AD, so that's AD here. This whole thing has to be equal to this. So we've worked out that that's 9n so far. Alright, so let's look at the ratio here. So we're trying to find HD, which is equal to 3n, and AC we've found is 18n. So, if we think about how we can write this, let's go back to our original colour. If we think about AC, the ratio of AC to HD, well, that is 18n, and HD is 3n. This will cancel and give 6, which we can rearrange to say HD, by multiplying both sides by HD, is equal to the length of AC and dividing both sides by 6. And we have proven our result. Let's be mathematical and say, therefore. Alright, well, let's also do the next question. So question number 10. So in this question we're using our ratio again. So we've got G is the intersection point of the median. So if we draw in that median, like so, then we know for sure that the ratio is going to be K to 2K. Perfect. And what we can also do is we can use, we're trying to find the length AH here. So that's this length we're trying to find. Let's call it X. And to help us out with this, we can draw in another line to make some similar triangles in a sort of butterfly technique. If we draw a line perpendicular here, then these two triangles here will be similar. And we know the ratio. We know that if we can find, well, let's give this a letter here. Let's call it I. If we find the length of, and also this other one here, n, let's say, if we find this length AN, then we know that we can just double whatever that is and get our value of X because of the ratios of the sides. By the way, why are these triangles similar? Well, we've got vertically opposite angles here, and also another angle here is 90 degrees. So two angles, we can say that they're similar. Let's write the similarity statement and the reason. There it is there. So be careful when we're matching up our corresponding angles. What we're going to do to help us find this length IN is to draw in a parallel line here, because we see that we have 90-degree angles here. If we draw in a line along here, we can make a rectangle. So we know for a rectangle that the opposite sides are equal, so this length here would be 2, which means that this length here would be 2. And what's more than that, we see that we have some parallel sides here too, so these two sides, IN and DB, are parallel. So let's see if we can find the similar triangles here. We can use this big triangle here, ABC, and the smaller triangle here, this doesn't have a, we haven't given it a letter yet, let's call it P, this point here. So we should write a similarity statement and reason for those two triangles. But we're missing one point here. We need a letter for this point here. So now we can call the triangle JBC. And so that's similar to PIC. Why are the angles equal? Well, they have a common angle here at C, and we have two 90-degree angles. So that's enough to say that they're similar. All of the angles are equal. Now we have some information here. We've got that the side length here is 2 over here. We also know that AI was a median because it goes through G, and that means that these lengths here are equal. So that means that the ratios of the sides must be in the ratio 1 to 2. So if the big length here is 2, the corresponding side must be 1 here. So this length here, oh sorry, that should be more over here. IP is equal to 1. I'll just make that clearer. IP is equal to 1. Alright, so now that we have that bit of information, we can find what IN is. IN, the length of IN, is equal to 3. So if that's 3, well then, if we want to find X, let's use back to our original triangle. X, the corresponding side we found was 3. That must be equal to the ratio from the other two matching sides. So the corresponding sides there were 2K and k. Alright, so simplifying, we get what we expected, x is equal to 6. We knew that as soon as we found that this was 3, x was just going to be double that. There are no units in the question, so we can just say x equals 6. Well, so it was a long video. I hope you enjoyed it, and we'll see you in another one.